right, guys. So in the warm-ups, I asked you to go through and fill in as much of this chart as you can. So what's another name for 0 in radians? Just 0. What's 360 in radians? 2 pi, right? Let's go through, let's do all the radian measures first, and then we'll go back and we'll do the sine, cosine, and tangent. So what's 30 degrees in radians? 180 divided by what gives us 30? What's this one? Pi over and 60 and 90 and 180, 1 pi, right? And 270. Right, so we needed 90 times 3 to get the 270. So our goal today is to actually figure out how the unit circle works. And I really want you this year to just get a really good understanding as to why it works and how it works rather than trying to memorize everything. I'm not going to be really huge on the memorizing. I know it says in bold here, memorize these values, but I want you to also just kind of be able to understand and figure out what the answers would be. We're first going to look at 0 or 360 degrees. That's what we call a quadrantal. I just have a scratch piece of paper here just to show you this. Here's where 0 or 360 is. For these quadrantals, we are always going to make the radius 1 for every single triangle or angle that we look at from now on in the unit circle. That's because unit circle, a unit means 1 unit. So we're making the radius 1. If I make the radius 1, what is the point right here? 1, 0. And so therefore, if I'm finding the sine of 0 or 2 pi, it's going to be y over r. You have to remember that sine theta is always y over r. Cosine theta is always x over r. Tangent theta is always y over x. So therefore, what is the sine of 0 or 2 pi? It's going to be y, which is 0 over 1. So it's going to be what? 0. So you should have had 0 right there. Now we're going to figure out the cosine. Well, cosine is going to be x over r. So what is that going to be? 1. And then the tangent is going to be y over x. And so what is that going to be? 0. Now they want us to write this as a point x, y. So if I'm thinking about this as a point, what is this as a point? 1, 0. All right. We're going to do all the quadrantals first. So what's the next quadrantal when we come to? 90 degrees. Okay, so now let's look at 90 degrees right here. What's that point going to be if the radius is 1? That's going to be 0, 1. Okay, and so now did you figure out what's the sine going to be for 90 degrees? If it's y over r, what's it going to be at 90? 1. What's the cosine? 0. The tangent is going to be y over x, so what's that going to be? Undefined. And then writing it as a point. That's the point 0, 1. All right, for pi, coming over here to pi, this point right here is going to be negative 1, 0. So what do you get for the sine? No. Sine is y over r, so it's going to be 0. What's the cosine going to be? Negative 1. What's the tangent going to be? Y over x, 0. And that point right there was negative 1, 0. All right, let's go to 270 degrees. Let's do the point first. What is this as a point, you guys? 0, negative 1. So I'm going to write the point first this time. 0, negative 1. Remember, r is 1. First, we're going to find the sine. Sine is going to be y over r. So what's it going to be? Negative 1. What's the cosine going to be? What's the tangent going to be? Undefined. Good. Now we're going to go to 30 degrees. Okay, so I'm going to do a 30-degree reference here. I'm going to create this triangle for you. And we know with a 30-degree angle, we normally have this going 1, radical 3, and 2. However, what did I say now? I always want the radius to be of this circle. 1. What am I going to have to divide this by to make it have a radius of 1? So I'm going to divide this by 2. I have to divide this by 2. I have to divide this by 2 in order to keep it in that same ratio. As a point now, how far over did I go to the right? Radical 3 over 2. How far up did we go? 1/2. Here's how I want you to write this then as a point. At 30 degrees, we were over radical 3 over 2, and we were up 1/2. Remember how I created that for you right there? Now we're going to talk about how to find the sine, cosine, and tangent. So for 30 degrees, the sine is going to be y over r. What did I now say our r is always going to be? So what is y over r going to be here? 1/2. X over r. Well, r is just 1, guys. So what is x here? Radical 3 over 2. Okay? Tangent is going to be y over x. If I have 1/2 divided by radical 3 over 2, I have to do 1/2 divided by radical 3 over 2. Well, to simplify that, I just multiply by 2 on top and bottom. And I'm going to get 1 over radical 3. How do we rationalize that? What's it going to end up being? Radical 3 over 3. Good. Okay, so that was for a 30-degree angle. Guys, when we do the unit circle, every 30-degree angle is going to have this same point. So if this point was radical 3 over 2, 1/2, over here, where I have this other 30-degree reference, what's the angle going to be over here such that I have this 30-degree reference? What's that angle going to be? 150. It's going to have to be the same triangle in there. So it's still going to have to be radical 3 over 2, 1/2. But what's going to happen in this case? X is going to have to be what? Negative. Okay? So when we get to doing the unit circle, we're going to think, okay, if I know this one, I know this one. See how it almost makes like it's like a reflection over this y-axis here. This ray goes over to here, and that's where that 30-degree angle is, and it would be the same point. Same thing down here. You should now know what this point would be. Does anybody know? It's negative radical 3 over 2, comma what? Negative 1/2. Okay, what about this point over here? What is it going to be? Right. Okay, so that's with a 30-degree reference. We're going to come back to this. See how it looks when I look at all these 30-degree references? Some people like to think of it as like a bow tie look. See how it almost looks like a bow tie there if I look at all those? All right, so this angle's 30, this is 150. What's the next one? In this quadrant, guys, with the 30-degree reference, what is it? 210. What is it in this quadrant with that 30-degree reference? Can you tell me what that is in radians, 330? 11 pi over 6, right? Okay, and then we're going to use those points. We're going to come back to this in a minute. I really want you to understand how it all works. Okay, 45 degrees. I'm going to use another piece of scratch paper here for 45 degrees. Just watch. So now I'm going to have a 45-degree angle. That's right here. How do those sides normally go on a 45-degree angle? 1, 1, radical 2. But what did I say we always want this hypotenuse to be? So what am I going to divide by? Radical 2. I want this to be a 1. So I'm going to divide by radical 2. Now I want to know what this point is. How far over are we in the x direction? Not 1/2, sorry, I forgot the radical. So we're over 1 over radical 2. What's another name for that? So this is radical 2 over 2. This is radical 2 over 2. Okay? So now let's put that point down. The point at 45 degrees is radical 2 over 2, radical 2 over 2. All right. Then the sine. What's the sine going to be? It's just going to be the y value now because r is 1. So what's the y value? Radical 2 over 2. What's the cosine? What is the tangent? What's anything divided by itself? Y over x. 1. Good. All right. Tell me the other angles in the other quadrants. This is 45. What's the angle over here in the second quadrant with that 45-degree reference? Good job. What about in the third quadrant with that 45-degree reference? Right? And in the fourth quadrant, what's it going to be? Right, 315. Very nice. See how we again get that bow tie shape? See if you know what this point would be. We'd still have that same 45-degree triangle. Do you know what this point is? Good. Okay, so it's the same thing except x is going to be negative. So this is going to be the same thing, but what's going to be negative? Both of them. What's going to be negative here? Y. Very good. We are making good progress. All right, moving on to pi over 3, which is how many degrees? 60. Moving on to 60. Drop it down perpendicular to the x-axis. With a 60-degree reference, I know that across from the 30 is 1, across from the 60 is radical 3, across from here's 2, but I want this to be a 1, so I divide through by 2 to get a unit circle, right? Now this point, I'm over 1/2, and how far up? Good, okay? So there's my point. My point is going to be over 1/2, and radical 3 over 2 is going to be the y value. Now, the sine is just going to be y. So sine is going to be what? What's this one? What's this one? Radical 3 over 2 divided by 1/2. Think about it. What is it? Radical 3. Very good. Okay, when we get to that unit circle, we're going to have, oops, wrong line. We're going to have this. We're going to have this. See the bow tie that's getting created? We're going to have this. Okay. So what's this angle going to be in the second quadrant with that 60-degree reference? 120 is going to be the angle, right? And we know that the x is going to become negative. What's the angle going to be that's going to go here all the way down to there? 240. Can you tell me in radians? 4 pi over, no, 60 degrees is pi over, so it's 4 pi over 3. Good. Okay, all the way around here, what is it? It's 300 degrees. We know it's a pi over 3 angle. What is it? Good. And then you would know the point. What's the point? 1/2, and then what else? Okay. All right, let's come over here now. Now, we've got the unit circle. We have the whole thing here. I guarantee you, once you get going on this, you're going to find it very easy. I'm going to do some sporadic points with you, and then I'm going to want you to fill it in on your own, because that's how you're going to learn the best, is to really practice it on your own. All right, I'm going to give you this point, 1, 0. I'm going to give you this point here, up here. You all should know that, 0, 1, right? This point here, what is it? And what about this point down here? So what we're going to be doing is, on the inside, we're going to write all these angles in radians, okay? You should be looking for patterns. On the inside, we're writing all the angles in radians. Okay, let's go. This is 0 or 2 pi. 30 degrees is what? Pi over 6. Let's go quickly, guys. 45 is, 60 is, 90 is, 120. What's the reference angle? Think of the reference angle first. What is it? 60 is the reference. So we know it's pi over 3. 60 times what gives us 120? 2. So it's 2 pi over 3. 135, what's the reference? 45. So we know that's pi over 4. So times what? That's 3 pi over 4. 150, the reference angle is 30. 30 is 180 divided by 6. 30 times what's 150? 5 pi over 6. 180 is pi. Okay, look at this pattern here. Now I like to go to all the 30-degree references because I know all the 30-degree references have to be pi over 6s, right? Darn it. Well, I can leave the pi. That's not going to matter. Pi over 6 here. Okay, so pi over 6, 5 pi over 6. Do you know what this one is? 210 is going to be 7 pi over 6, right? 210 is 7 times 30. We just did this one a minute ago. What was it? 11 pi over 6. See how it's kind of nice just to do all the 30s? Now let's go through, let's do all the 45s. 45, 135, what's the next 45? 225 has to be a pi over 4. What's that going to be? 6 or 5? 5. It's 5 45s. Okay, 315 has to be a pi over 4. What is it? Some people are saying 6, some are saying 7. 7. Okay, let's go on now to our 60-degree references. We already did that one. We did that one. Here's the next one with a 60-degree reference. What's 60 degrees? Pi over what? Okay, so 60 times what gives us 240? 4 pi over 3. Here's our next 60. This is pi over 3. 60 times what is 300? 5 times 60, so 5 pi over 3. And then how many? 270 is like a pi over 2 one. How many 90s to get to 270? 3 pi over 2. Okay, good job. We got all the angles done. Wasn't so bad, was it? All right, let's go to the next thing. 30 degrees. Can you remember, like, are we longer in the x direction or the y direction for the 30 degrees? X. So which number is larger, radical 3 over 2 or 1/2? Radical 3 over 2. This has to be radical 3 over 2, 1/2. Guys, if you know this point, go ahead and fill in everything that has a 30-degree reference. We found this one. All right, did you get them? Everything's radical 3 over 2, 1/2, except some of them should be negative. Down here, you should have both negatives. Over here, just the y is negative. Okay, does that make sense to everybody? All right, let's go on to 45. Do you remember what that one was from our chart back here? All right, it's that radical 2 over 2, isn't it? So we're going to have, this is going to be radical 2 over 2, radical 2 over 2. Easy. Go through, do all your 45s. All right. You got it? All right. On to our 60 now. Now, guys, look at this pattern. I think this is so cool. I used to use this, but I don't use it anymore. But I would think of this as radical 4 over 2, radical 3 over 2, radical 2 over 2, radical 1 over 2, radical 0 over 2. Do you see that pattern there? So what's radical 1 over 2? Since we got radical 3 over 2, radical 2 over 2, this is radical 1 over 2. But what's radical 1? 1. So this is 1/2. Look at the y's. We go from 0. You can basically think of it as radical 0, radical 1 over 2, radical 2 over 2, radical 3 over 2. Okay, so now we got our 60s. Fill in all your 60s. All right, you just filled in the unit circle. Pretty painless, right? Okay, now you have to be able to use it. All right, trig values. We used to say it was y over r, but what did we just make it so r is always equal to in the unit circle, r equals 1. So now what is sine going to be equal to? Not y over r, just y. What is cosine going to be equal to? Just x. Tangent, we still have to do what? Y over x. Okay. Okay, what about the signs, S-I-G-N-S, in the quadrants? Is sine, what's true of everything in the first quadrant? All positive in the first quadrant. Positive, positive, positive. What about in quadrant 2? Is sine positive or negative in quadrant 2? Positive. What about cosine? Cosine in quadrant 2, guys. Negative. What about tangent? Negative. Quadrant 3. Also, guys, remember that whole all students take calculus. Not my favorite way, but, you know, whatever. Some people like it. Okay, what about in quadrant 3? Is sine positive or negative? Negative, because the only thing that's positive is tangent. So sine is negative, cosine is negative, and tangent, when we have a negative divided by a negative, is a positive. And finally, quadrant 4. Look, guys, everything has to have 2 positives and 2 negatives. If you get this far, you should know what it is without even looking up here or thinking. What's sine? Negative. What's cosine? What's tangent? All right. Okay, now using our unit circle, I'm not going to do every single one of these, but I'm going to kind of sporadically do them. Way too many problems here to practice. We don't need them all. Sine of 3 pi over 4. We can do this the old way where we draw a picture, we go to 45 degrees in the second quadrant. We know it has to go -1, 1, radical 2. We know sine is opposite over hypotenuse. 1 over radical 2 is radical 2 over 2. That's the way we did this yesterday, right? Now, what we do, though, sine of 3 pi over 4, if we know this unit circle, we've got to have like a picture of this, like tattooed in our brain. And we go to 3 pi over 4, and we look at the y value. And right there is the sine. It's just radical 2 over 2. We can literally just look at the unit circle to find it. Okay? All right. What do you think we would do if we're trying to find the sine of negative pi over 6? What is negative pi over 6 the same as?
11.
It is, very good. It's 11 pi over 6, and it's also -30, and it's also 330, right? So whatever works best for you. The old way to do it, we would have drawn a picture, put our 30 degrees in there, filled it in. But the new way is we go to our handy dandy unit circle that we know, and we're going to go to -30 degrees, which is the same thing as this, and we're finding tangent, so we're going to have to do y over x. All right, so look, we're going to have to do -1/2, looking around, -1/2 divided by negative radical 3 over 2. What's a negative divided by a negative? Positive. And then what's going to happen to the 2's? Cancel. Can somebody tell me what it's going to be then? Radical 3 over 3. Good. You know, and sometimes if it's one of these types with tangent or cotangent, I actually think it's easier just to go back and do that whole triangle business and put my -1, my 2, my radical 3, and just do y over x. I think it's a little quicker sometimes. Okay. See how we get the same answer? Oh, sorry. This should be a positive here, shouldn't it? Did I have it as a negative? No, I just looked at it wrong. This should be a negative on that. Negative radical 3 over 3. Good thing I checked with that. All right, guys, cosecant. Cosecant is going to be r over y. What kind of angle is this? This is just the what? 90, quadrantal. So when you look back at 90, what's it going to be? 1. Good job. So we're just going to have 1 there. Okay, we'll do one more. We'll do cotangent of 5 pi over 3. So if you use your unit circle, go to 5 pi over 3. Doing cotangent is going to be x over y. Is our answer going to be positive or negative? Negative. And what's 1/2 divided by negative radical 3 over 2? Right, that's another negative radical 3 over 3. Okay, and then just to finish up, let's read these. Find the measure of theta in degrees over the interval from 0 to 360. I'm going to show you 2 ways to do it. I'm trying to find what is the angle that has a sine of 1/2. I can do this the picture method where I draw triangles. I put my opposite here, my hypotenuse here. What's the missing angle? 30 degrees. So I know the answer for theta has to be 30 degrees. But where else would I get a positive 1 for y? Which other quadrant? Quadrant 2. So I can say this is 1, this is 2. And then what's the angle that starts here and ends here? 150. Now, using the unit circle, all I have to do is look, where is it that y is 1/2? Y is 1/2 here, y is 1/2 here. So my answers are 30 and 150. So how many answers do you think we're going to have for most of these? 2 answers. All right, I want you guys to think about this one for a minute. See if you can figure it out. Number 8. When you think you know it, raise your hand. Got 1, 2, 3, 4, 5, 6. Caitlin, what do you think?
225 and 315.
John, do you agree? You don't? What do you think? Okay, some other people had their hands up. What do you guys think? John? Okay. All right, so Caitlin, do you agree with John now too? Okay, so 225, that would actually give us, look, all students take calculus. I'll do that kind of silly thing there. 225 is in this quadrant, so tangent is positive in that quadrant. There we go. So let's get rid of that one. Those 2 are correct. Very good. And were the rest of you able to figure that out? We're looking for, we have to have y over x being the same values, but one positive and one negative. So where that happens is right here. See how right here, that divided by that would give us -1. Okay. All right. Next one I want us to take a look at is, let's go down here and do this one. Cosecant squared theta plus 1 equals 2. So to solve this, I have to subtract 1 first. I get cosecant squared theta equals 1. How do I solve this for just cosecant? Take the what? So I'm going to take the square root of both sides. So cosecant theta has to equal plus or minus 1. What's cosecant the same as? Yeah, it's the reciprocal of sine. So cosecant is r over y. Well, what does r always have to be? So if r always has to be 1, then I know that it's really y that has to be plus or minus 1. Because r has to be positive 1, always. So to get plus or minus 1, the y value has to be that. Do you guys know what it would be? Are you getting to where you can visualize it without looking at the unit circle? No, not yet? It's okay. It'll come. What do you think? Josh, did you think you know it? No? Anybody know it? Thought I saw. There we go. Sam?
90 degrees and 270.
Do you guys agree? 90 degrees and 270? Where y is positive or -1? Look at the circle. Look at all the y values. The only place where y is 1 is right there at 90. The only place where y is -1 is right there at 270. Make sense? Okay. Let's do these last two. I'll do this one, and then we'll see if you guys can figure out that one. All right, secant theta plus 2 equals 0. So secant theta, I'm going to have to subtract 2 from both sides, has to equal -2. Secant is not on our unit circle. We only have sine and cosine on the unit circle. And remember, on the unit circle, cosine is the same thing as x, and sine is the same thing as y. Keep that in mind as you're working on this. So if I have secant, I have to change it into cosine. So what do I have to do to this to change it into a cosine problem? Flip it over, do the reciprocal. So cosine has to be -1/2. If whatever's faster for you, you can go back to the unit circle, or I'm just going to draw a little sketch just to remind you can do it this way too. Sometimes you just want to go back and do it this way. It might be quicker. What's the reference angle, guys? What goes across from the radical 3? 60. So what's it going to be? 120 and 240, right? Or you can think of the unit circle, and you could know that at this 120, that's where we get the -1/2, and at the 240, that's where we get the -1/2. See, next year, you're going to have all these memorized. Like, you're going to have to know that the sine of 30 degrees is 1/2. And then you have to figure it out based on the quadrants and everything. Okay? All right, you guys try 12. See if you can do it. Anybody know? You might think they know one answer. Yeah, what do you think, Jeremy? Okay. Here's what I want to point out, though. These directions say we're going from 0 to 360. You're allowed to use an answer of 0, but not 360. So you said 180 and 360. So what do you want to? There you go. Good job. 0 and 180 is correct. So all we're looking for is, where is y 0? So if we're thinking of that unit circle, where is y 0? Y is 0 right here at 0, and y is 0 right here at 180. Okay? Yep. No, because of the directions saying from 0 to 360 with a parenthesis here, a parenthesis means you could use 359.99999, but not 360. All right, guys, any questions? It's a lot for day one, so don't feel stressed if you don't quite understand it yet. You just want to practice the worksheet, either draw your triangles or use the unit circle, and kind of push yourself, guys. The one thing that really helps to know is basically if you know the sine of 30 degrees. What's the sine of 30 degrees? Visualize it. Just visualize the triangle, guys. What's the sine of 30 degrees? 1/2. If you know the sine of 30 degrees is 1/2, you should know the sine of 60 degrees has to be what? Radical 3/2. Okay? Start making these connections as you're working on the homework, okay? And eventually you're going to get it memorized just by doing so many problems. All right, make sure you do worksheet 9.42.